This is a GCSE Physics presentation looking at states of matter. To get started, you just have to name the 5 states of matter, and then you got to explain what's different between each of the states of matter. Pause the presentation, come up with the best answer you can. After 2 minutes, restart the presentation and continue on and check your answers. So pause now. Well, the 5 states of matter, you should be able to name at least 3. The solids, liquids, and the gases. And those are the 3 that we're going to focus on even at GCSE, but there are actually 5, which includes plasma and the Bose-Einstein condensates. Now what's different about them? Well, they've obviously got particles and different arrangements and so forth, but the main difference is the amount of internal energy that we find in each of the states of matter. So in this lesson, we're going to look at some simple models to show solids, liquids, and gases and the arrangement of particles. And then we're going to identify and describe the processes involved in changing from one state of matter to another. To get started with, we need to define the term particles. Well, particles are small bits of matter that make up the universe. We can refer to particles, we can actually be talking about electrons, protons, atoms, or molecules. So there's a lot of terminology we can use the word particle to cover, but make sure you are clear in what we're talking about. There are 3 subatomic particles that make up an atom on the right hand side. You should also be able to identify the black circles and the large lump in the middle. Pause the presentation, spend a minute, just identify the names, don't worry about writing anything down, and you can restart the presentation, check your answers. Well, the minus signs around the outside, there are the electrons. The positives in the center are the protons, and the orange represents the neutrons, which have no charge. Remember, the large lump in the middle is called a nucleus, and the rings which the electrons orbit around are known as shells. When we talk about changing states of matter, we're talking about how substances move between being a solid, a liquid, or a gas. Remember, each of those different states of matter has their own unique properties, and you can move from one to another by either absorbing energy into a system or releasing energy from a system. Why is it known as a physical change when we change from one state of matter rather than a chemical change? Well, the simple reason is that the material recovers, it's completely reversible. The change is not permanent. Chemical reactions are permanent changes. You can reverse a reaction, but you have to do another chemical reaction to reverse it. Let's have a look at the states of matter. In a solid, the blue circles represent particles. Remember, particles are not exact circles, it's just a representation. But in solids, we have particles packed together in a regular fashion, so there's a clear pattern. They're packed close together. They are able to vibrate, but they cannot move. They are stuck to one spot and simply wobble side to side. They are not able to take a step forward or backwards. They're fixed to one place. Now, do the particles have to line up in straight lines of columns and rows like you see in that arrangement? Well, the answer is no, they don't. As long as it's a regular pattern, a repeating pattern, then it's a solid, but it doesn't have to be rows and columns, as you can see from the picture on the right hand side. In terms of liquids, one of the biggest mistakes that people make when drawing liquids is they draw the particles all separate and all spaced out. That normally represents a gas. In liquids, most of the particles are still in touch with each other. They're still closely packed. There's still contact with at least half the particles inside that arrangement should be in contact with each other, if not more. However, there is some free space and there's no regular pattern. There is enough room for those particles to move past each other. Now, why do particles in a liquid move? Well, it comes down to the fact that they've got more energy. Particles in liquids have more internal energy than the particles in solids. In gases, the particles are now spread out. They're essentially individual. They're shooting off fast and in random directions. There's no preference, they just whiz off in every direction. Remember, in real life, gases occur in 3D, so if we could, they'd be coming towards you and away from you on the screen as well as all the other directions. Why does the gas appear to have less particles than the same mass of solid or liquid? There's fewer circles in the picture. Why? Well, it's not to do that we've lost any substance or lost any material. It simply comes down to the fact that the particles are so spread out that the other particles no longer exist inside that little box. The best analogy you can get is if you imagine that you've got a room with a solid that we turn into a liquid and turn into a gas inside it. If you're looking at the solid, liquid, and gas, you can see the whole thing. However, if you just put a little window in the wall and looked into the room through that little window, when you've seen the solid, you'd have lots of particles visible at the window. As we turn it to a liquid, the particles spread out more, so some of them may not be seen because they're no longer visible in the window. They're still in the room, they're still there, you just can't see them through the window. And when you turn into a gas, we have even more spreading out of the particles, so you see even fewer particles. The other particles are still in the room, you just can't see them through the window you're looking at, and the window represents the little black box in the diagram. Now, conservation of mass, this is what we mean in terms of when we go from one state of matter to another, the number of particles doesn't change. So if we take a certain mass of a particular substance and we put it into solid, liquid, or gas state, the mass will always be the same. The only thing that will change is the volume, because the same mass of a gas takes up a lot more space than the same mass of a solid. So volume changes, but the mass is conserved. The mass stays the same unless we add or remove mass from that particular system. And what is the unit for mass? Well, it's kilograms. Please remember kg is written with a lowercase k and a lowercase g. So kilograms is always written in lowercase. So we've mentioned this internal energy. Well, when particles move and vibrate, they have energy involved. Movement involves kinetic energy. There's also potential energy stored in that system as well. And all that kinetic energy and all that potential energy put together of all the particles in a particular substance or system, that's what we refer to when we talk about the internal energy. When we heat substances up, we are increasing the internal energy of those particles and therefore increasing the speed of those particles. Hence, in a solid, they're not moving but vibrating. In a liquid, they move, and in a gas, they move really fast and spread out randomly. It's all about the amount of internal energy that the particles have. Now, there's a very special temperature, which is minus 273.15 degrees Celsius. And it's a temperature at which particles have no heat or movement. That temperature is given a very particular name, and it's a temperature that we have yet to reach. We have never got anything to this temperature. What is the name of that temperature? Well, it is absolute zero. And as yet, we have not got particles to absolute zero. We're very close, but we haven't got there yet. Now, what you have to do now is you have to identify the names of the processes involved in moving between solids and liquids to gases. And then you also have a term that refers to the specific temperature at which each of these processes will occur. Pause the presentation, try and come up with some answers, give yourself 2 minutes and then restart the presentation and see how you've gone. So pause now. Well, the four processes, when we're turning from solids to liquids, we call it melting. When it's going from a liquid back into a solid, it's freezing. From liquids to gases, or boiling or evaporation, and from a gas to a liquid, we talk about condensation. And when we talk about the specific temperatures, we're not talking about numbers. What we're talking about is the melting point, the freezing point, the boiling point, and the condensing point. Remember, when we're talking about changing states, we talk about either energy being absorbed into a system or energy being released from a system. If energy is being absorbed from a system, we have an increase in the internal energy of the particles, so the particles move faster and spread out more. If energy is released from the system, the particles move slower and eventually get to the point where they're only vibrating around a fixed point. They also become less spread out and more organized and regular in pattern. Now, there are specific instances when you can go straight from a solid to a liquid and straight from a liquid to a solid. Now, the two processes involved are deposition and sublimation. For most GCSE courses, you only need to be aware of sublimation. I don't know why they only let you do one, but for some reason it only covers sublimation, but I'd suggest that you remember the term disposition as well, and it would only be a simple straightforward question in the exam asking to name the process of when you go straight from a solid to a gas. What is the name of the process? They will not ask you going from a gas straight back to a solid, but I'm going to suggest that you memorize it anyway. It's useful information for later on. And just to finish off, 5 quick questions, multiple choice. Pause the presentation, go through your answers. You can simply write A, B, C, D, or E, and when you're ready, you can restart the presentation and check how you've done. Well, there are 5 states of matter. We have which state of matter fixed position. Well, they're fixed in a solid. The correct units for mass, remember, it's a lowercase k and a lowercase g. Particles move because they have internal energy. And which process does not involve a liquid state? Well, the only one you need to know about is sublimation.